Yes, we come back with the next video of problem number 9. It says that y is given as 4 sine theta by 2 plus cos theta minus theta, and they tell us to prove that it is increasing on the interval 0 to pi by 2. So as before, previous problem maybe 7th or so, where they have given us the intervals. Also here the interval is being given, so that, as I told you, always reduces your work. We only have to talk about the derivative and ensure that the derivative is positive in that given interval. That's all. So let's see now how we can do it. So for that, obviously we have to go for the derivative. So let's take the derivative dy by d theta. We can clearly see that this is a rational function, so we'll go for the quotient rule and get the derivative that way. So it is 4, we can keep it as it is, 2 plus cos theta, derivative of sine theta minus sine theta into derivative of 2 plus cos theta by 2 plus cos theta the whole squared, and derivative of theta, of course, we know is minus 1, so that we can write there. Now we move across and we'll try to get these derivatives. 2 plus cos theta, derivative of sine theta we all know is cos theta. So also sine theta as it is, we are finding the derivative of 2 plus cos theta. 2 is a constant, doesn't have a derivative, and cos theta has got the derivative minus sine theta. So like that, this becomes minus sine theta. Let's expand this. 2 plus cos theta the whole squared. So this works as 4 times, let's open it, 2 cos theta plus cos squared theta plus sine squared theta by 2 plus cos theta the whole squared. Now this we know is 1. Sine squared theta plus cos squared theta is always 1. So let's write it like that. 4 into 2 cos theta plus 1 by 2 plus cos theta squared minus 1. Now since we have to decide the sign of dy by d theta, it's better that we simplify this and get across a simplified answer, so that will help us to work. So let's kind of simplify. For simplifying, here we'll have to equalize this denominator by multiplying both the numerator and denominator by this expression, so that we have the denominator equalized. So therefore we are now coming up with the expression. Let's open this bracket. 4 into 2, it's 8 cos theta plus 4 minus 2 plus cos theta whole squared by, we have equalized the denominator, so the denominator now is 2 plus cos theta the whole squared. So when we try to open it up, let's see what comes up. It is 8 cos theta plus 4. Now this is a plus b the whole squared, a squared plus 2ab plus b squared. So that way it is going to be 4 plus 4 cos theta plus cos squared theta by 2 plus cos theta the whole squared. So that way it is 8 cos theta plus 4 minus 4 minus 4 cos theta minus cos squared theta. This can be simplified and this is cancelling by 2 plus cos theta the whole squared. Okay, so how much is this coming to? 4 cos theta minus cos squared theta. Yeah, so we could have the cos theta coming up, cos theta 4 minus cos theta by 2 plus cos theta the whole square. So our question is that in the interval between 0 to pi by 2, this function is increasing. So if you have to show that, we have to consider the interval between 0 to pi by 2 and ensure that this particular thing is positive there. Now for ensuring that this is anyhow positive because it's a square, cos theta is going to be positive because the interval is between 0 to pi by 2. Between 0 to pi by 2, all cos values are positive. So this is also positive. That's not a problem. Now, we are very clear that between 0 to pi by 2, if you carefully look, no, for the values of x between 0 to pi by 2, how is the cos theta values varying? Cos 0, it's 1, and cos pi by 2 is 0. So you have all the values between 1 to 0, 1 half, 1 by root 2, root 3 by 2. They're all in fact positive values. So therefore this is a positive value. In that sense, 4 minus, when we subtract, it is definitely going to be a positive value. So as such, this expression is positive, but we need a small explanation for it. So let's write over here. Here, for 0 less than x less than pi by 2, cos theta, not x, it's theta, cos theta is positive, and 2 plus cos theta whole squared is positive, being a square. I continue here. Also, cos theta for 0 less than theta less than pi by 2, cos theta is between 1 and 0. So as a result, 4 minus cos theta is definitely positive. It can be half, it can be root 3 by 2 or whatever. Then in that case, 4 minus that half, or 4 minus root 3 by 2, or 4 minus 1 by root 2 is anyhow positive. So it is going to be positive. So that way dy by d theta is going to be positive, because all the things there is positive. So dy by d theta is positive, and therefore that's how we prove that y is increasing function in y is an increasing function in 0 to pi by 2. That's all. So that's how we prove, quite interesting. What is the logic that we are using? We simplify it, and then we present a proper argument to show that yes, it is positive and things like that. So please do follow all this, subscribe the channel, and invite more friends for the subscription and popularize the channel. Thank you.